Hi there, and welcome back to another ParaView tutorial. So far we have covered a lot, mainly qualitative post-processing. So we cover, the most common filters that you're going to use in ParaView. You have it here. But let's move to a little bit more quantitative measuring quantities. We computed forces in previous videos. We're not going to address that here. You can follow the same steps, but just to show you measure quantities and so on. But before doing that, I want to show you some extra few tricks, since that we might find useful when moving to the next step, quantitative, post-processing and measuring quantities. So something that I would like to show you here, sometimes people ask me that you have that geometry. In this case, you clearly can see now that it's not very smooth. If it is possible, for whatever purpose you want to do it, smooth the geometry or retriangulate the geometry in ParaView. So that can be done. I want to stress something using the basic filters that we have. There are some extra plugins. There is a very good one, call it VESPA. We have a video. It's very good. I recommend it to use that, but I'm going to show you how to do that smoothing and retriangulation, subdivision using the basic filters. So let's work in the geometry here. So we have this triangulation. So recall the video with the streamlines that we will release from the surface. Okay, and remember that you release from the nodes or from the cell center, but let's say that you want to release from more points. So how do you retriangulate that? So that is very straightforward. So as usual, go to filters and it's user search to remind you that you have a lot of filters. So you have the documentation come here now in Python documentation, then a lot of tutorials, many things, very good. This page is very well documented, ParaView. Then in the Python documentation here, you will have available reader sources, and then you can search all those filters that you have there. Okay, so in particular, I would like to use, you go search, and they have subdivision. So see that you have loop subdivision and also subdivide, okay, but I cannot use it. So remember, when they are gray out, they're likely unique to extract surface node. So let me go here, search, and let me go like this, extract surface, okay. I'm just only extracting the surface. I'm not doing anything, so just convert it to poly data, whatever it's telling you, when you try to use that filter. So now I can use that one. Let me go subdivide. Okay, you have this two subdivide, loop subdivision, so you can go to the documentation. So let me go in particular now the loop subdivision. Tends to be it works very well, but it can be very aggressive. So here you go, you have it, and you have the explanation there. And actually the loop subdivision is due to this guy, not that, because it's looping. It's Charles Loop that developed that. In any case, so let me use subdivide. So it's just pretty much put 2 and it will subdivide that. Let me go here, let me reselect. So this is what is happening. So recall the streamline filter. So if you want to have more points to release, that's the way to do it. Remember, you can apply this subdivision. Also, you can do a selection. Okay, let me go back here, and for instance, let me select here and add, and I want to, okay, let me do something like this. So let me select those patches. You can do like this, you extract that, you have that, and you can look there, you have this triangulation, and you can apply that. Okay, I need to, let me go here, as you saw the extract surface, and then here you can subdivide, and I can go, for instance, 4, and there you go. You apply that, so let me deselect that, let me put this here, and there you go. So now you can release more streamlines for this specific patches. You can do another selection and so on. So as you see, it's very flexible. Contrary, people say that you cannot manipulate the STL. Here, as you can see, you can do manipulation, selection. In particular, for those working with OpenFont, you can do selection of faces, separate. It's a little bit not time consuming, you need to select, but you have the lasso selection and so on. So moving on here, so let me go here So we have the subdivide, and let me do something here. Let me split the screen. I want to render in this one and show there this one. Let me go here and let me link the view. So I select this one or this one, it doesn't matter. Okay, right click and link camera, and then select the other view, and then the two cameras are linked. Okay, so select here and now. So basically this is different. We just subdivide. So we were talking that maybe I would like to smooth this one. Okay, from the original one I want to smooth this one. So usually to apply a smoothing is better to do in a finer mesh. So I will do in this one, but have in mind that you can apply the smoothing also here. So you go here, and as you can imagine, there is another filter. It's called smooth. Okay, and you apply that filter there, and there you go. So let me put a solid color there, and let me go here. I don't want the triangulation there. Surface. So as you can see, nothing, it didn't change much. There are some different, but it didn't change much. But remember, this is iterative method, so you need to increase the iteration. So let me put 200 there. And there you go. So now you have a smoother surface. This you can export, and then again, talking for those working with OpenFOAM, this STL you can use a smoother, nicer STL to do your simulation. And later I will release, now we will work in the video to do this particular simulation, because some people ask me, okay, what I want to do is simulation. So first we finish this one, we will do that. But something that also will want to point out, that when you do this smoothing, maybe these problems will arise. Now look at this. Well, while you are smoothing, these surfaces are not going to be meshing. So you have here this gap, so maybe your mesh is going to leak there. So this is an issue to point out. Now that you have this very nice plugin. Now let me put it here. Is VESPA ParaView. It's a fantastic plugin. This is the one I recommend to use to do this stuff. I'm using the basic filter in ParaView, but I recommend you to use this plugin. Okay, we have a video also now using this one. I'm working as well with an aircraft. So one way to fix this issue, okay, is that if I come here, look at that. I have this surface now separated in different objects, different sections. So what I will need to do is to merge everything together. So there is a very useful filter that maybe will come in handy later. So when you have scenes like this, you can then merge everything. So let me apply this. Let me go here and let me apply it in this one. Okay, I was doing subdivide here, so we'll apply it here, and filters, and again you search merge, and here you have it, merge blocks, apply, and it will merge everything. So now let me hide this one, and I have this one. As you can see, we don't have any more the BTK subdivision. It's just a single patch. And to show you here, you go into here, you have the BTK, the parts or the index for each individual surface. Here we merge everything. So now if you do that operation here, this smoothing, you are not going to have any more that issue. Okay, so let me do it here. Recent. Okay, again here you need to extract surface and filters. You go smooth, and let me go here and see that issue that we were having there, we don't have it anymore. And let me here, smooth one, let me bring that one here, and it was there. So see that so as you can see, there is a lot of stuff. There are many filters now, so play around, read the documentation. I'm going to show you, this is an extra tricks now to show you, because later now we're going to find it useful, maybe in previous video, for the stuff that I mentioned, the string lines, if you want to add more points, or you can apply the trick with the planes and the cut planes and so on, the slices. So it's up to you. So see that their problem kind of fixed. Let me put here 200 and a smoother geometry, and to show you as well the other filter, because you have the loop one that tends to be better, but it can be very, very aggressive. So let me put here loop subdivision. So pretty much it will do the same, but within not the subdivision, it will smooth at the same time. So let me do 2 subdivisions. And there you go. So yeah, it didn't work very well here, but you get the idea. Also be careful because these operations, they can be heavy. Okay, so you need to have good video card. So let me put 4 there. So look at that, this one, it will take some time. Even if it seems to be an easy operation, it takes not a long time to do all the iterations, smooth everything, all the triangulation and so on. So let's see what we get here. Okay, there you go. So as you can see, this time it took longer time to do all the operations. Didn't improve much, but well, took a long time. You can see there the reason why it took a really long time. So these are the filters that I wanted to show you, just to show you another trick, but mainly related to visualization. Let me put another view. Let me put here, this is moves there, and let me link this one. Right click here, link to this one, and we link the views, and then let's link everything, link with this one, everything link. So look at that, you have these 3 views. Also to show you this one, you can come here and view, equalize view, okay, horizontally, everything is equal, the same. Let me put it here, and to show you mainly visualization. So the original triangulation will be this. Oh, let's put this one. Okay, this one was the triangulation, and there you go. Okay, so you have that triangulation. Then we have the smooth, subdivide, and smooth. Okay, so there. And let me put exactly the same, smooth, okay, but let me now add another filter here. And remember, this is mainly for visualization. And let me apply surface normals, or surface normals. So I will compute the normals. And if you pay attention, you will see that the visualization, it is smoother here. Remember, I didn't do anything. The only thing that I did was compute the normal. So basically this normal is how shadows and the rendering is done. So you have nicer images, just compute also surface normals, and things will be much nicer. Oh, there you go. So remember, I didn't do anything, or ParaView didn't do anything besides computing normals, but that normal computation is just when it comes to casting shadows and rendering, it improved the visualization, just a visual effect. So now to show you, to end this video, a trick, we added a few new filters. Sometimes also it might happen that you want to subdivide something, and to show you, let me add a source here, and let me create a plane. Okay, I have that. Let me close everything. Okay, let me zoom here. Okay, so you have this plane here, and surface with edges, and see that it's just straight plane. So what you need to do is you want to apply subdivision here. Subdivide is not going to work because it's not a triangulation. Okay, so you need to triangulate that one. For that you have a filter called triangulation. Okay, so as usual, let me set a plane, set the extract surface. So you go filter, search, triangulate, apply, and then it has been triangulated. And now that it has been triangulated, you can do the loop subdivision. So it's up to you. Let me put, you can put whatever value you want there, so be careful that can be kind of expensive. And as you can see in the processes doing so, that having that triangulation, well, you miss some in the corners, it smooths out everything. And actually I was using now the loop subdivision, so I used the wrong one. Let me use normal subdivide, and let me put 8. This one will keep everything without having this smoothing, and there you go. Okay, so if you have a surface that is not triangulated, you have the triangulation, and you have different filters now to do tetrahedrization and so on. So let me write this one down to show you. That was an extra trick. I will hide everything, and to end here, let me show you apply everything. So I have the aircraft, let me put this one here, and let me in the domain extract the isosurfaces of Q criterion, and let's apply the same smoothing to the isosurfaces, so you will see the effect there also in the volume. This is not only limited now to this boundary, so you can extract something from the volumetric regions. I want to stress that, be careful that large meshes, these operations can be heavy. So let me extract there. Okay, it's probably too large. Let me put a smaller value to see a little bit more. There you go. So let me color this by Mach number and see that clearly. You can see here now the tetrahedrization now. So this stuff can be smoothed quite easily. So let me go, and you have your triangulation, and as we did previously, you can triangulate that. Okay, let's do it. So subdivide. Let me apply level 2. So I'd subdivide that by 2. Let me split my view. Let me put it here. I want to see that here. And put the aircraft structure face here. Let me link views. It's this one. Okay. And here, I got lost in translation here. Okay, I want the initial contour. Here I want the Mach number, and in this one I want that. So there you go. So basically pretty much the same. I haven't done anything but to show you what it changed here, that I apply here the subdivision. Run 1 subdivision is here. It's really here. Okay, clearly you can see it has been subdivided, and the original one. Okay, so everything applies. So extra trick, and now let's apply the smoothing here. Filter, smooth. Let me put 200 in there. Smooth that filter, and like previously, now we have kind of a large triangulation here. It takes time, give you the warning again, all these operations, be careful, that can be time consuming. If you don't have a good car, sometimes it will crash immediately. Let me do like this. Let me put here smooth, here this, let's view, let's equalize view, and let me link this one to this one, and everything is linked. I want my surface here, and here I want my Mach number, and here I want to see this. So here you have the comparison. Okay, so original, subdivide, so there is no difference between these two besides more triangles, and here when you smooth, you have a nicer representation. So let me increase the smoothing here to 500. That will take some time. Okay, so after a while, look at that. Now you have this one much smoother. You don't see now the spikes that you get there. So the effect of the smoothing. So for rendering purposes, it's showing nicer images. There you go. You have that. Again, it's this data. For instance, this data is on a steady, and you do this. Well, that will be an expensive operation. To show you finally the comparison also with the surface normal. So let me go here. Okay, let me put here the smooth one. Okay, here also I can leave this one. Okay, and now let me in this one, on top of this one, let me add surface normal. Mach number, and then there you go. So see, that is a much nicer visualization. Kind of this feature you can see here has been no, but just for the effect of rendering. Okay, so remember, I didn't do pretty much I didn't do anything here, just compute normal. So if you want to improve your visualizations, surface normals can be very helpful. And finally, because this is getting too long and I want to show you in another video another very nice trick before moving to the render. So let's enable there the ray tracing. And I sound like a broken record on this, but be careful, you need good video cards. And I can see my GPU now. No, the fan is on fire, very loud. Hopefully you don't hear that. And there you go. You have a very nice visualization. So the original surface, then here we subdivide, and then we smooth, and here exactly the same, but we apply surface normals to improve the rendering. So these are tricks now that we can use to improve all the visualization. So yeah, that's all now for this video. I show you now the extra filters, subdivide, smooth, merge block, and some extra commands here in view to organize things. So let's move to the next video to show you how to split the surface, something that can be very helpful now for the quantitative post-processing. Thank you and see you next time. Bye.